Alright, so in this video we're going to look at adding and subtracting segments and angles and how it works into showing triangles and congruent. So first we're going to look at adding angles and adding segments. So let's say we have a segment and we're told a segment like this, and we're told AB is congruent to CD. So let me tick mark that. So those are the same. So what this is telling us, of course, is that those two red lengths are equal. And we have this segment in the middle, this yellow one, the segment BC. And hopefully it should be obvious that since this red here is the same as this one, I could add the yellow to each. I could extend AB by BC, and I could extend DC by BC as well. And that means that the segment from D to B is the same as the segment from A to C. And that's just adding segments. So BD, that length, must be the same as AC, because you can add BC to both of the things that we were given as being congruent. So here's how this looks. Here's how you write this up for proof. To make this as familiar as possible, I want you to write it up like you're adding or subtracting equations like you did in Algebra 1 and Algebra 2. So I have a congruence right here, AB congruent to CD. We're going to write another equation underneath, and we're going to add the equations. So we're going to add BC to both of these. So I have BC congruent to BC, and I'm going to add them up. So when I add these, I got AB plus BC, and you have to look at the picture to see what you get. When you take AB and you add BC to it, that's going to give you AC. And on the other side, I've got CD plus BC, and again, you have to look at the picture to see what's going on. CD and BC added together give you BD. And so, from knowing that AB is congruent to CD, we can conclude that AC is congruent to BD. And so in proofs, you'll write it like that. You'll have a box with the information above, the congruences you're going to add, and then you'll add them up and write addition as your reason underneath the final box. So you're telling me when you write this that if I take this congruence and add this congruence, I can get this congruence. Let's look at addition of angles. So let's say we're given this information. Angle ABD is congruent to angle DCA. Angle DBC is congruent to angle ACB. Let's mark that. ABD is congruent to DCA. That's the red pair I've just marked there. We've got ABD, that's this angle. DCA, that's this angle. And then we've got, I'm not going to go through details, the second one that is these two green ones. Angle DBC here, angle ACB there. Again, it should be clear, since the red ones are same, and since the green ones are the same, if we add them up, we get this larger angle is congruent to that larger angle. Like say if the reds are both 20 degrees and the greens are both 30, then we know when we add them up they're both 50. So we can conclude that those two blue angles are the same from knowing these two facts. Given this and this, I can add those together like adding equations and get a new congruence. So here's how it will look when you write up proofs. You'll have, we're taking angle ABD and DBC. That's over here. ABD and DBC here. When we add them together, we get angle ABC. We get the blue one. So these two angles added give me that blue angle ABC. And on the other side, the red and the green angle give me the blue angle DCB. This is how it looks when you write up proofs. These are both given facts. If you add them, you get this. And I wrote addition over here because I'm adding this congruence to this one to get a new one. We can also subtract. So let's say we're given this information about segments, and we'll mark it. Now, we have a little problem marking AC congruent to FD, because when you look at AC, it goes all the way from here to here. Where do I put the tick mark? Here? Or here? Where do I put the tick mark to show that A to C matches? Because we've got this point in the middle, B, and we're not sure. So what we do is we put a bracket around the edge, and then we tick mark the bracket to show that all the way from A to C are congruent. So it looks like that. So there's some brackets that says A to C is congruent to F to D. We don't have a problem with the other congruence. AB congruent to EF. Oh, okay, I colored those yellow. Those yellow links are the same. The other ones look like that. We tick mark them, and those I colored those pink. So we can subtract here. We've got the yellows are the same, AC and FD, and then these parts are the same. So if I remove each of the pinks from the yellows, what's left over down here have to be the same also. I'm subtracting equals from equals. Do you see that? I hope you see that. So that's going to tell me BC and ED have to be the same. The yellow lengths match. The pink lengths match. So if I remove the pinks from the yellows, these down here at the bottom will match. And here's how it looks when you write it up in a proof. AC minus AB will give me BC, that's the left-hand side. AC minus AB will give me BC. And on the other side, FD minus FE gives me the leftover part ED. So we're subtracting, we're removing a smaller piece from the larger. And again, we're lining it up like Algebra 1 and Algebra 2, subtracting equations. I have this congruence minus this congruence gives me this congruence. We can also do this with angles. So let's say I get told angle ZAX. In this picture, angle ZAX is congruent to angle WAY. So that's those two. ZAX is this one. WAY is that one. Notice that these two angles overlap. There's a part of the arc that they share. I can remove that overlapping bit from each, and what's left over would have to be the same. So here's how I write that. Oh, okay. I said a little more. So I'm going to remove that pink section from each of these. So that pink section is angle YAX. So I write angle YAX congruent to angle YAX is congruent to itself. I want to subtract congruences. So here's a congruence. I'm going to subtract this one. The top fact is given. The bottom fact is same angle. And now, angle ZAY is this blue one. Right here. That's ZAX. Take away the pink part. And on the other side, we're going to have angle WAY minus the pink part, and that will give us that blue bit in there, angle WAX. And we write subtract underneath. So this is how we show that we are adding or subtracting segments or angles in proofs. So let me do two triangle congruences that use this, and then we'll be done. So here's our first one. So we're given a pair of congruences. We want to prove two angles congruent. And then I mark the congruences. BC is congruent to DC is up here. AB congruent to DE down there. Now I want to prove this triangle is congruent to that triangle. So let me color those. Those triangles are overlapping. So the pink one is triangle ACD. The green one is triangle ECB. I want to prove that those are congruent. Well, this is a little bit tricky because of the information given. First of all, let's look at this tick mark here. This tick mark, it's a partial side of the pink triangle, but I don't need partial sides. I need complete sides for SAS and ASA and those things to work. This green, that tick mark here is a partial side of the pink, but it's a complete side of the green triangle. You see, that BC is the complete side of the green triangle. So I'm going to color that tick mark green to show that it's a tick mark on the green triangle. Likewise, on the other side, this tick mark is a complete side of the pink triangle. So I'm going to color that tick mark pink. In addition, these two angles, we saw this last block day, they have a shared angle up here at the top. This angle C at the top, that angle there, oops, I drew some extra stuff, is a shared angle. It's an angle in both triangles. So we're going to have to figure out what congruence condition we want. So, and I've already given it away by what I've drawn, but let's look here. Here's a side. Let's look at the green triangle. Here's a side. Here's an angle. Okay? ASA would require this angle, but I don't have any reason why this angle would match its counterpart on the other side. None of the givens are going to tell me angle EBC is the same as angle ADC over here. So let's look at the other possibility, SAS. Here I have this green side. Here I have the shared angle. So if I want to go SAS in the green triangle, there's the green triangle. If I want to go SAS, it's going to be side, angle, and then it's going to be this whole side. Look at the green. Side, and then the angle at the top, and then that whole side. So I need a reason why C to E, the side of the green triangle, is congruent to the corresponding side C to A of the pink. In other words, I need a reason for this triple tick mark being the same as this triple tick mark. It's not given. But you can see, hopefully now, this is tricky, the way we're going to get that those are the same, that this is the same as this, is we're going to add, and we're going to take this one tick mark plus this 2, added together, AB plus BC, give me A to C, and on the other side, ED plus DC, give me EC, the other thing I want. And so there's how I get my side, angle, side pattern between the two triangles, side, angle, side. Notice we don't use this directly in the congruence because A to B is not a side of either triangle, but we're going to use it to add to this to get a complete side of the pink triangle. So let's look at how this writes up. We're going to prove the two triangles are congruent by SAS. I always start with the triangle congruence because that's sort of the linchpin of everything. So now I have to assemble my information. So I've got the pink and the green triangles are congruent. So BC congruent to DC is one pair of sides, that's a given. The angle at the top, angle C congruent to angle C, that's just because it's the same angle, same exact arc. And now the other pair of sides, is this in the green, E to C, is congruent to this in the pink, A to C. AC congruent to EC. But the reason I know that is I get that by adding together the two givens. If you notice, the givens here are what I need to add. If I take BC plus AB, that will tell me that AC is congruent to ED plus DC, which gives me EC. So above here, I'm going to write my addition construction, how I add two things, like I showed on the previous couple slides. So I've got BC congruent to DC, AB congruent to DE. Those are both givens. And when I add them, I get AC and EC. Take a look. BC plus AB is AC. DC plus DE is EC. And that's it. I'm done. I've shown these triangles are congruent by SAS. Pair of sides, pair of angles, pair of sides. One more. This one with angles. So here's a bunch of information. And I'm going to mark it in my diagram. OLM is congruent to OPM. That's those angles down there. LO congruent to PO. And then I've got these overlapping angles, NOL and MOP, that are the same. Now I want to prove LM is congruent to NP. I want to prove this here. So I'm going to put question marks. I want to show that those are congruent. The reason I'm using question marks is because if I put tick marks, that may deceive me, thinking that it's something I already know is true. And I don't want to be misled by the marks. I'm putting question marks to say I want to show that these are congruent, but I don't know they're congruent yet, so I can't use that as a side in an SAS or an ASA or something like that. So let's look at what we've got here. I've got a bunch of angles and sides, and I want to show that this side here, NP, this segment, is the same as LM. So what I want to do is I want to find a pair of triangles that have LM and NP as their sides. I want to make sure it looks like I've got information in around to show that those triangles are congruent. That's the strategy. I want to find a pair of triangles that have this and this as their sides, and then see if I've got the information I need. And you try to pick them so that you do. So the two triangles I'm seeing here are the ones I've done in pink and green. I've got triangle LOM over here in pink, and triangle PON in green. And I'm going to try to show that those two triangles are congruent. And once I've shown that, then that tells me that these two sides have to be the same length, corresponding sides of the two triangles. So, I've got a pair of angles. I've marked that one in pink, that one in green. I've got a pair of sides, that and that. But notice the other pair of angles I've given go outside the triangle. That's frustrating. This arc goes from OL over to ON. It goes outside the triangle. So I can't use them directly as given in the essay, in the ASA. I can see I'm building an ASA argument here. I need to make them smaller, but because they overlap, the two congruent angles overlap with this matching part, I can subtract that part in the middle away from each of those two angles, and then what's left is two angles inside that are two angles of the triangle. So that's the strategy. I'm going to remove these two angles. We're going to remove MON from each of these two angles, and what's left over are the pair of angles I need. That red and that green angle. So, I'm going to notice, again, I'm starting with the triangle congruence. I'm going to start LOM, PON. Those are the two triangles I'm going to show congruent. I'm going to use ASA. So, one pair of angles and one pair of sides are just givens. Angle OLM and angle OPN, that's a pair of angles in the two triangles. LOPO, that's a pair of sides. This is an actual pair of angles and an actual pair of sides in the two triangles. The other pair of angles I'm going to get by subtracting. I have to take the given pair, which overlap, and remove the central portion from each, and then it will shrink them down to the angles I need. I need angle LOM and angle PON to match. That's the red and the green. And the way I get that is by subtracting. If I do NOL minus NOM, look over here, NOL, that's this arc, minus NOM, that's that middle piece, then I'll be left with LOM. NOL, take away the middle piece, is LOM. And on the other side, MOP, given, that's this arc, right in here, minus the matching middle section, NOM again, will leave me with just this green angle. So MOP minus NOM gives me PON. So if I subtract this congruence, take this congruence, subtract this one from it, I will get the angle I need to complete my ASA. So I give reasons for those facts above, given and same angle, I write subtract. And we're pretty much done. I wanted to show that LM and NP were the same, but those are clearly LM and PN are matching sides of those two triangles. So I say corresponding sides. Okay, that's it. Be sure you answer the questions in the Google form that go with this so that I know that you've had a look at this video. Thanks for listening, and I will see you on the next block day.